Hi, now we are going to see the concept of file allocation methods in operating systems. Um, so before going to that concept, we are going to discuss some general things. Normally we are creating many files in operating systems. So these files are going to be stored permanently in a secondary storage device. There are many secondary storage devices are available. So we are using hard disk widely. So within hard disk there are many disks are there. So each and every disk logically divided into blocks. Files also create files also divided into a number of blocks. These blocks in file, the file within file they create a lot of blocks. These blocks need to be stored within disk block. How can we store these blocks into secondary device? For that we are using file allocation method. Now we can discuss the concepts which are given in the slides. An allocation method refers to how disk blocks are allocated for files. In many cases, different files are stored on the same disk. The main problem for the OS is how to allocate the spaces to these files in an efficient manner. There are many methods are available. So out of these, three are important ones. One is contiguous or sequential allocation, linked allocation, indexed allocation. So which algorithm we can choose it? Selection of an appropriate allocation method will significantly affect the performance and efficiency of the system. So we can see one by one. First one is contiguous allocation method, also called as a sequential allocation method. In contiguous allocation method, each file is copied set of contiguous blocks. So for example, so these are the 4 files, not 5, there are 5 files are there. All these 5 files are stored in a disk. Assume there is a disk which contains totally 32 blocks, blocks 0 to 31. So this directory structure contains 4 files. This directory contains not 4, 5 files. So first file is count. Totally it required 2 blocks. Where do these 2 blocks are stored? These 2 blocks are stored within disk. What is so starting 0? Starting at 0, totally it occupied 2 blocks in a continuous manner. That is 0 and 1 allocated for count. So like that for next file tr, it required totally 3 blocks. It starts at 14th, that is 14, 15 and 16 allotted for tr. Then mail, it required totally 6 blocks. These 6 blocks are allocated in a continuous manner starting from 19, 20, 21, 22, 23, 24. So like that for remaining 2 files. So within contiguous allocation, the files are stored in a continuous blocks. So the directory contains which are the information? There are 2 informations, starting block as well as number of blocks allocated for this file. These are informations are stored within directory table. Next, this contiguous allocation having some advantage as well as disadvantage. Advantage: best performance in most cases. Simple only starting location and length are required. So if you want to read file or write file, if we know the starting block as well as length of the block, simply you can read it. So we can also access record block randomly. That is also possible. Disadvantage: so finding phase for a file is difficult. So knowing file size, also external fragmentation. These are disadvantage. These that is the external fragmentation disadvantage can be overcome by using compaction technique. Is compaction just collecting all the free blocks and make it as a group. So this group can be allocated to a particular file. This can be done either downtime, that is offline, or online. The next technique is linked allocation. In linked allocation, disk blocks are arranged in the linked list form, which is not contiguous. So file ends at nil pointer, no external fragmentation within this. Each block contains pointer to next block. No compaction required because no external fragmentation. Free phase management system called when new block need it. So if you want to store a new file, so you need to call the free space management system, which will provide list of free blocks. Within that the file can be stored. Improve efficiency by clustering blocks into groups, but increases internal fragmentation. This is an example for linked allocation. Assume there is a file G. It starts at 9th block. So within 9th block the data is there. Also a pointer available within that 9th block which point next block. So what is the next block? 16. 16 pointing block 1, 1 pointing block 2, 2 pointing 25. 25 is the last block. The pointer of 25th block is null. The pointer value of 25th block is null value, not null. So it contains no address. There is a null value it contains. The as -1 may be there. So advantages of this method: there are no external fragmentation with linked allocation. Any free block can be utilized in order to satisfy the file block request. File can continue to grow as long as the free blocks are available. Directory entry will only contain the starting block address. This is also having some disadvantage. Random access is not provided. Pointers require some space in the disk blocks. Any of the pointers in the linked list must not be broken, otherwise the file will get corrupted. Need to traverse each block to get the data. The third method. So first one is contiguous allocation. The disadvantage of contiguous allocation overcome in linked allocation. Linked allocation having some disadvantage which also going to be overcome within this indexed allocation. So within indexed allocation, each file has its own index blocks of pointers to its data block. Indexed block does not hold the file data, but it holds the pointer to all the disk blocks allocated to that particular file. So directory entry will only contain the index block's address. So logical view, assume this is a block, index block. Index blocks contains only pointer to the data blocks, assume. So see, there is an example. So the file G, so its index blocks is 19. The index blocks contain the files data block. So which are the files data block? 9, 16, 1, 10, 25. So these are the 5 blocks containing data for the file G. So these 5 file informations are stored within this block 19. Block 19 contains pointers to, so these 5 blocks. So what is the advantage of indexed allocation? Supports direct access. A bad data block causes the loss of only that block. Disadvantage: a bad index block could cause the loss of entire file. That means if index blocks is corrupted, so we cannot retrieve that file. Size of the file depends upon the number of pointers an index block can hold. Having an index block for a small file is totally wastage. More pointer overhead. So these are the So these are the three methods of file allocation. We are generating a lot of files. All these files are stored within disk in a secondary storage device. So any one of the method is followed, each one having advantage as well as disadvantage. Depends upon the file size, importance of file. You can choose one of the method for file allocation. So thank you for listening.